Hello, this is Mr. Abbott. This is Exploring Quadratics with Graphs and Tables. Quadratics video number 2. This is the second one of Unit 6. We have already talked a little bit about quadratics and what they're made up of, what they look like. Today we're going to get into the graphs, a little more detail of the graphs, and also the table of values, so we can kind of get some information on that as well. Now we'll start with a couple of reminders. We are doing quadratics, obviously. When we graph a quadratic, we're going to get a parabola, which if you have forgotten, is a shape that looks like this, like a U, and that U can be either going upward or open upward, or it can be opening downward like this. We have a vertex, which is going to be right here at that tip. It's also the minimum or maximum point. The quadratic is very obvious what it is by the x squared versus the x when it's linear. Thus, we don't get a line. And a parabola is going to be symmetrical. That means, like right here, you will have a line that you could fold it over at. Another line here, you fold it over. And that's good because we get these corresponding reflecting points, which we'll talk more about here in a moment. A couple different reminders. Some of the things we talked about the axis of symmetry. That is that line that we can fold over. That is that line of symmetry. And if you've forgotten, the formula for finding the axis of symmetry, if you have the equation, is x equals negative b over 2a. Also remember that the equation for a quadratic equation is y equals ax squared plus bx plus c. So that's where you get the a and b from, the opening coefficient and the middle coefficient. We're also going to be graphing on a calculator a lot more today. And remember, when you graph on a calculator, it's all the same, except when you go to put it in, you're going to have that same button. You always put the x, theta, or not, t, I think there's an n on it. That'll get you the x. But then the second button, to get the squared, make sure you push this button. Okay, that'll give you the y equals x squared. The x and then the squared is what you need there. Let's also talk about the corresponding or reflected points. We mentioned this, or I mentioned this a little bit in the first video, but I haven't talked much about it. I want to show you more in detail here. You notice we have our axis symmetry right down the middle. And here's our vertex. Now, because this is symmetrical, notice how when the line goes up like this to the right, I get to this point right on the line, it is exactly 1 unit to the right. If I go to the left, I'll stop there, exactly 1 unit on the left. Okay? Those are reflected points. That's why it's symmetrical. If you fold it along this line, those two would match up. We go to the next one that's right on the line, and it is 2 units to the right. So its corresponding one is also 2 units to the right. We can keep going up to here. We find another one that is 3 units to the right, and now its corresponding is going to be 3 units to the left. And that's great because what that means is if you're trying to create a table, you find this point, the vertex, maybe you find this point, and this point, and this point, and you found the vertex and 3 other points, but what you've really found is the vertex and then not just 3, but 4, 5, and 6 other points. So you find 4 points, you get 3 free, which is very helpful to you when you're trying to come up with a table of values. Now, just because I didn't mention, say, this point, doesn't mean it doesn't have a reflecting point. We just picked these because they're right on the line, so they're nice whole numbers. But this one, you'll notice, is about 2.5 units to the right, and its corresponding one is about 2.5 units to the left. Now let's look at some tables. We've talked linear for a long time. Linear looks like this, where you have 3x. Here's quadratic, we have 3x squared. We're going to compare the two. On this one, I've already set the table up. I took the -4, plugged it into the x, got 3 times -4, gave me -12. I plug the -3 in there, 3 times -3 is -9. Plug the -2 and so forth, and I get -6, -3, 0, 3, 6, 9, and 12. Now notice here the pattern we've got going. This one is going up 3. This one is going up 3. This one is going up 3. Up 3, and so forth. Any 2 points you pick on here are going up 3. It's very consistent. That's why it's linear. Over here we have quadratic. We have the x squared. Now what happens here is when I put in this first value for x, I'm going to have -4 squared. It's going to be 3 times -4 squared. Well, -4 squared is 16. 3 times 16 is 48. I plug -3 in here. I have 3 times -3 squared, so 3 times 9, 27. And you can see my y values here. There's a pattern. But if we look at the differences, this one's going down 21, this one's going down 15, going down 9, going down 3, up 9, up 15, and up 21. We have a nice pattern, but not consistent. This is quadratic. You get a pattern, but it's not a consistent, different at the same time. Now, if we look at just the quadratic, we can look at the table, and from that table, we can find all the information we found from the first video by looking at the graph. We can find the vertex. And this one's a little tricky, but as you can see, it's going to be fairly easy. We're going 48, 27, 12, 3, 0, 3, 12, 27, 48. There's an obvious pattern. It's going down, 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 gets to 0, starts going back up. Okay, this graph is going to start up high, come down low, and then go back up. This vertex is this point where it starts going, where it's coming down and starts going back up. Okay, the vertex here is going to be right there at that point, the point 0, 0. Now, once you find the vertex, the axis of symmetry is easy. There's your x value, so it's just x equals 0. Our domain, the other day in the first video, we said it was negative infinity to infinity. That was all good, but we're going to start saying it's all real numbers. And hopefully that'll appear a little bit better later. Okay, our range almost always will look like this, be y. We have a minimum point here, which means we're going above it, so it's y is greater than or equal to 0. Let's look at our next example. We have negative 1/2 x and negative 1/2 x squared. Our linear one, you can see the same thing is happening. It's going down, 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 down by half each time, or by 0.5 each time. Nice and consistent, a nice line. This one, you notice our values are different. They go negative 8, negative 4.5, negative 2, negative 0.5, 0, negative 0.5, negative 2, negative 4.5, and negative 8. That's caused, again, by this x squared. I'm really going to type in, if I were doing this on the calculator, I'd have 0.5. I'd probably put it in parentheses, and then I might put negative 4 squared. And that's going to give me negative 8. I can do this over and over and over, fill them out. But now realize, once I get to my vertex, probably if I were filling this out, I'd get to negative 0.5 and realize, hey, I'm repeating again. The last three are simple to fill out. So now let's take a look at that same equation. Let's come up with our vertex, axis of symmetry, and so forth. Our vertex, pretty simple to find out. It's going down, hits 0, and again we have another vertex of 0, 0. We're going to find out in a minute that that's not the only vertex we can possibly have. But our axis of symmetry, again, quite simple. We look right here, it's x equals 0. Our domain, all real numbers. You will get tired of writing that, but you will write it. Our range, we have y. Now if we think about this graph, it's starting at negative 8 and it's going up, and then it's coming back down. So that means we have a downward opening quadratic or parabola, which means this is a high point, a max point. So it's going to be y is less than or equal to 0 because it's all going to be below that. Taking a look at another example here, we have y equals 3x squared plus 6x minus 2. Now this time I've added a lot more to it. It's not just 3x squared or 1/2 x squared. We can take a look at the table. We have negative 422, negative 37, negative 2, negative 2, and so forth. Understand that I got these y values by taking negative 4, plugging it in there, and calculating it. So we start looking at the vertex. Notice it's here and it's going down, it's going down, it's going down. Now it's going back up. Each of these is going up. That means it goes to negative 2, then to negative 5, and then back to negative 2. This is going to be our vertex. Negative 1, negative 5. Which makes our axis of symmetry x equals negative 1. So finally, we have a vertex that isn't 0, 0. Our domain, as before, all real numbers. And our range, well, let's take a look and think about what this graph is going to look like. It's going to start at 22 and start coming down, hit that bottom point, go back up. That means we're going to have a y is greater than or equal to, and our vertex is negative 5, so y is greater than or equal to negative 5. And finally, one more. We have y equals negative x squared plus 5x minus 2. Hopefully by now you're seeing this negative and knowing, without having to think twice, that this is going to be one that opens down. Okay? As you get good at this and as you practice a lot of this, you realize that's going to help you with the range and a lot of other things. But here we have a vertex, and this vertex is tricky. That's why I put this one on here. We're going negative 26, negative 16, negative 8, negative 2, 2, 4, 4, 2, negative 2. We know there's a vertex. Here it's going up. It gets to this point right here, and then it starts going back down. But we don't have one single point. What that means, if we just graph these points and just these points, we'd get up here to 4, and then we get to the next one and come down like this. Well, that would give us a graph that had a nice horizontal line right there, and obviously a parabola doesn't. It has a point. So it's going like this, it just isn't making it all the way up to 5. And what it also means is that the vertex is somewhere in between here. So if you get 2 points like this, where the y's are the same, what that means is you split the difference. Our vertex is going to be 2.5. Okay? That's going to be our x value. Now, we don't know what the y value is because it's somewhere in between there as well. Our axis of symmetry is going to be x equals 2.5, simple enough, because again, it's coming from the x value. Our domain, as always, all real numbers. Okay. Now we have a range, and for our range, again, we're going to need this value. We'll come back to that in a minute. But this one is opening down, which means it's going to be y is less than or equal to. But now we have to find our y value. Easiest way to do that, if we know this is our x value, is to take this and plug it in for x, and plug it in for x, and just use the calculator. And what's going to happen is, now realize when you do it, you're going to get a number that should be a little higher than this. Not a lot higher, it should be 5, but somewhere between 4 and 5. If you calculate and you get 2.3, or you get negative something, you've calculated incorrectly. It's got to be around this number. And when you put the 2.5 in there, what you're actually going to come up with is 4.25, which means your range is going to be y is less than 4.25. Finally, in conclusion, a few notes. Notice that quadratic equations do not increase or decrease evenly. That's how you can tell. A linear equation would be going up the same difference. Quadratic equations follow a pattern, but they don't increase or decrease evenly. Second, if you can find 1/2 the parabola, then you can always find the other through the corresponding or reflected points. It's just important to know. Next, the vertex is the point where the y values begin to go back in the direction that they came from. So they're either going up, hit a point, and go down, or they're going down, hit a point, and go up. Next, if you can't see the vertex in the table, use the equation in the formula x equals negative b over 2a, which is the axis of symmetry, to find it. You'll get x equals something. Well, that x will be the vertex x. And then you can take that x value, plug it into the equation, and it'll give you the y value, so you can find it that way. Finally, before you come to class, make sure that you've looked over the next page of your packet, the front and the back. Shouldn't take you too long, but go through and answer those questions, kind of refine some of your definitions and refine some of what you've learned. And also, when you do get to class, pick up a calculator, plug some of these equations in, explore, look at it, make sure that you can do it. Make sure you can go to the table and you can kind of follow it that way, because it's one thing to see it on the screen like this, but it's a lot more valuable to you if you can go and learn how to do it. Save you a lot of time. Thank you.